All right. Hello, everyone. Good evening. Guys, let's make it a little interactive. Can you see me? Can you hear me? Please put plus in the chat if everything's good. Awesome. Very good. All right. So it's just me today, and I am pretty excited because we're going to continue to talk about one of my favorite topics. I'll try not to make it extremely boring, but sorry if it is. It is going to be interview questions, software development lifecycle, and types of testing. So today we're going to cover types of testing again. I'm sure you probably barely covered them at the very beginning, but we're going to do it again just to make sure that you remember them right before you are going to search for jobs. And I'm sure that like after the course, it's a little bit more clear for you, like what are they, what different types are. So I'll give you my perspective on that. Then we will move to software development lifecycle, and I'll walk you through the whole process of developing a feature so you understand how different company teams actually communicate, work on different projects, and how they eventually deliver from one end to the very final release. And then if we have time remaining, we'll cover our remaining interview questions. But if we don't have enough time, don't worry, because you're going to see me again tomorrow, and we will talk also about more interview questions tomorrow, and cover more topics tomorrow as well. So let's begin. I'm actually going to start sharing my screen. Let's see. There we go. Okay, so you should be able to see my screen right now. And actually, let's start with types of testing. And that should be good. Okay, so let's start with type of testing. I'm probably going to turn off my video for now, so it doesn't actually distract. And let's quickly go over types of testing and look at different things again. So the very first thing, the thing we talked about yesterday, and the thing I'm not gonna point a lot of attention today, but just a quick overview. The very common separation, the most common things that people in the industry know, that testing can be black box testing, can be gray box testing, and can be white box testing. I personally like this picture a lot because it actually gives a pretty good visibility on what it actually is. So black box testing, it's when we basically test something and we have no idea what's inside. Gray box testing is basically when we test things and we know some information about maybe algorithms, maybe the structure of our application, about how API works or whatever. So we have some knowledge. And the white box testing is when we have all the knowledge about our whole application, how it works, we have access to the code, and we can test specifically against the code. So quick comment over here is that we will actually not do white box testing as manual QA engineers ever. White box testing is something that ideally our developers are responsible for, and they should be doing it. Sometimes they require some help from software developers and test, and we can help them with that. But as manual QA engineers, you do not do white box testing, so you can like relax and you won't have to do it. But this being said, I think it's good for you to actually have some understanding on how white box testing actually looks like. So please don't be afraid. I'm just going to show you a couple of test cases. So you have just understanding what it is, because for many people, I actually see a lot of confusion and they're like, oh my God, what is white box testing? How they actually test things from inside. So from developer point of view, white box testing will be looking basically like code. If you look at my screen right now, I have one tiny little function written in Python, and this function actually calculates the amount of items in user's cart. So let's say user is making a purchase in online store, and every time user clicks add to cart button, user can actually put something to cart, and it's actually added to the cart. All right, sorry, we have some background noise. Let's fix this. 1 second. Okay, perfect. So basically, let's say we have a card, user adds something to the card, and every time user adds something to the card, basically user then sees this counter of the items in the card that's being updated. So the test, white box test for this will be to verify something like, hey, if user has no items in the card, 0 items, upon adding 1 item, he has 1. If user has 2 items in the card, upon adding 1 more item, he has 3. If user has, for example, -1 item in the card, in this case, we have to verify that there is actually an error, and something like this cannot exist. So those are simple examples of white box tests. And when developers test, what they do, they just run their code. And upon running, you can see that code automatically executes the test. So this is what white box test case is. Again, you will never have to do it in your life. I'm just showing it to you so you have some idea on what it is. It's not like developers are actually taking mobile device and going around the room trying to actually look into the code inside mobile device. They simply work with code. That's the point. Okay, cool. Let's continue. And the next separation of our tests and our test types is very famous split. So all tests pretty much can be split into 2 categories. They can be either functional or non-functional. Basically, functional tests and functional testing is a type of testing that verifies that the functionality of the software or application works as expected or works as required in the specs. So functional tests are tests like, for example, you click on a button and something gets executed, or you turn on the video in your application and it starts playing, or you take a picture with your application and it's taken, or you send someone a message, or you link a card, or you make a payment. So really functions, so things that do something. Those are functional tests. So basically tests that try to verify that the function of your software operates and works as expected. So the second popular category in this case is non-functional testing. And non-functional testing checks some of non-functional aspects, as you can probably guess. So those, the most common ones are user interface. So for example, when you open the page, let's say we open a Google page, for example, non-functional test would be to verify that, hey, we have this logo, it's in the middle of the page, we have this bar has this shape, these buttons have like this gray background, and the whole page background is white, right? So UI, right? Simply just making sure that it is as expected. Things like font, for example, the certain size of your letters on your page, the certain colors, this is also non-functional test for this particular page. At the same time, if you enter the search word, my favorite, and hit enter, this is going to be a functional test, right? You verify that when you enter something, you click somewhere, it actually is working. So this is functional. The way the page looks is non-functional. It is a UI testing. There are other kinds of UI testing. There are things like performance testing. For example, how fast is your web page actually loading? Does it take it 2 seconds to load, or does it take it like 15 seconds to load? And usability, reliability, and things like this. Usually, we as manual QA engineers, when we work with application, we do functional testing 90% of our time. And we spend maybe 10% or so on non-functional testing, and we usually test around the user interface. We usually don't spend time doing like performance, usability, reliability testing. People in big companies sometimes do, but usually they are either some engineers devoted to this, or designers, especially if you talk about usability, for example. And it's usually not like in the scope of just a manual QA engineer. Okay, let's move on. The next types of testing are, and the next split is the one that we touched yesterday a little bit. Positive test cases, negative test cases, and boundary. So we talked a lot about happy pass, about golden pass, and all that terminology. So all that is usually referred to positive test cases. So positive testing is a type of testing that usually aims to verify that by providing a valid data, or by inputting valid data, your application behaves as expected. So basically, you enter something that is expected, some sort of valid data input, and then your application behaves the way it should behave. So a very common example here would be, let's go to DoorDash, for example, let's use some sort of a validation form. So I'm going to open sign-in page, and here we can see this email and password. So the positive test cases, in this case, the positive one, will be enter some sort of a valid email and some sort of a valid password. By valid, I mean it actually matches the requirements. Let's try this, right? And then we try to sign in. So this is a positive test case to verify that user who entered valid email, valid password can sign in, or if it's incorrect password, cannot sign in. Negative test cases are the test cases that aim to verify that your application handles successfully these situations when user does not behave as expected, when user inputs something that is not expected. So let's say you have an email field. A good negative test case will be to input something that is not a valid email. So here I'm missing the front part. If I hit sign in here, try and sign in like this, this is a negative test case. Blank entry, also going to be a negative test case. Something that is definitely not email, also a negative test case. Maybe valid email, but invalid password, only 1 character, is also a negative test case. And when we do negative testing, our goal is to make sure that our application actually behaves as expected and shows proper error messages for users. So user can actually understand what is wrong. And maybe user made a typo somewhere, and user can actually fix this input to make sure that everything is working. Another thing that gets into this particular group, but it's kind of on the side, is boundary testing. So boundary testing is basically a technique when we test around boundaries. So let's say we have a field where user can enter the age, and the user who and user is allowed to register if his or her age is between 18 and 150 years old. So in this case, we basically want to verify things around boundary. So we verify positive checks. So it basically partially includes positive testing right here, right? So we register a user who's 18, who's 20, who's 150, and verify that the user can register. So we verify these positive cases. And then we try input negative checks, negative values. So 17 and 151 are out of this range. So we also have to verify that when entering those, our application behaves as expected, right? So as you can see, boundary testing actually includes positive and negative checks. So that's why it's actually standalone one in this particular category. When you are asked, for example, do you come up with negative test cases? Always think about things that user shouldn't be doing. So a very common interview question, at least it used to be for a while, it's probably still is when person is at interview for a QA engineer, and they are asked, how would you test the calculator, and what are the negative test cases in particular for calculator? And very often people actually get confused and they start like saying something like negative numbers. No, when you do negative type of testing, it means you're trying to break something. It means you're trying to do something that you're not supposed to be doing. So what are the common examples for calculator, for example? Well, one of my favorite is divide by zero, right? So here we go. Another one is you can try to take a square root that by default can only be taken from a positive number. And you can try to take like a square root from -3, right? And see how your calculator behaves in this case. So when you do negative testing, that's basically the behavior that you're not supposed to be doing. Something that, like when you do something, you try to break things. That's a thing to remember over here. Cool. Okay. Now let's move on next, and let's see what I have over here. I'm quickly also checking on your questions. 1 second. Okay, so just to very quickly repeat one more time, when you do positive tests, you behave the same way users are, and your goal is to make sure that your application handles this properly. Your application behaves as expected. When you do negative test cases, you try to break inputs or break your application, do things that users shouldn't be doing. And your goal is also to verify that your application can handle this. And when you do boundary testing, you usually test around boundary values. So if you have, let's say, a field that has a certain limitations, you have to test around these particular borders and these particular limitations. So that is boundary testing. Okay, let's move on and let's continue to the next classification. Types of testing: unit, integration, system acceptance. So this one, I hope it's more clear from this chart, actually, and I hope you can see this. Basically, this breakage is more of like size of like piece of your application that you are testing. So I just showed you unit testing back a few minutes ago. Sorry, wrong one. And unit testing, as you can see, all I have here is one tiny little function. It's literally one function. Your application probably has hundreds and thousands of functions. So unit testing is testing one little function, and all tests cover this particular function. So it's called unit, basically, because it covers literally one tiny little component of your application. So something inside your app, some certain feature, some certain function, something very small. This is unit testing. Unit testing should be done by your developers, and we as QA engineers usually don't participate in unit testing because, again, that should happen at the code level. When they build the whole application, they also must build unit tests. So integration testing is one level up. It's basically a testing where you combine a few units and then you test them as a group. So this kind of testing is usually also made by developers. But sometimes some QA engineers can help them, especially QA engineers who do like API testing or database testing. But not usually not high-level manual QA engineers, but more like QA engineers who specify in a certain area. So integration testing is basically when you have a few units and you combine them together, and then you have to make sure that they work. So what I mean is, for example, let's say you have a functionality that is connected to the database. So user, let's say, is trying to register, and every time user is registering, we actually make a record of user and add this record to the database. So in this particular case, integration test would be a test that would create the user and then go check in the database that user is created. And it's usually done automatically also in the code. And it basically verifies that, let's say, the code base actually works fine with the database, just as an example. Again, usually made by developers. Okay, so the next level up is the system testing. So whole system testing is usually when we verify that different components of our application can work together, and they can work together as a whole full application. So our whole application performs functions and tasks the way it is designed. So, for example, we need to verify that our whole application can handle many users. So we can do the system testing. We can we can actually install our application, interact with us as a whole piece. It sends information to its servers, information stored somewhere on the server, and then user gets back some feedback on the screen. So for example, you submit a form and on the screen you see like, hey, this form has been submitted successfully and things like this. So the whole system testing. This is where actually QA engineers step in. And our manual testing of the application is basically can be part of system testing. System testing is usually like a whole more than just executing test cases. Like it can also include usability, recovery, and things like this. But at the same time, our manual test cases that we execute against our application are also part of system testing. Okay, and the biggest level, the very the largest last level of testing is called acceptance testing. So acceptance testing is basically this last level, and we test the whole system for accessibility, and we have to verify that our system, our application, actually behaves as expected per multiple business requirements and multiple requirements that we actually did for this particular application. So we go through the whole application, we verify that it fully behaves as expected, it has the features that are needed and required, and we literally test the whole thing. So now, acceptance testing sometimes can be also split and can have like subsets of testing and testing stages. So it can have alpha and beta testing. So when we go here, let's quickly reiterate just to sum up. Developers test on the unit level very small functions. They then test sometimes, but they should actually, they test into integration of components. So let's say make sure that their code works with database. Then we test the system, we test certain features, or we test components. Then we do acceptance testing. We verify how the whole application works, that it matches our requirements and everything is good. And then basically at this stage, we either release somewhere or we go deeper and extend our acceptance testing and break it into different pieces. So let's say QA has tested here. Product managers and the QA managers has also tested here. Now let's say we want to release our application, but we are simply afraid because it's a whole new application or a whole new feature, and we are not particularly sure that it is actually fully ready and that users won't have a lot of issues with this. So when we want to actually make sure that everything is ready and we try to release to like a larger categories of people, we sometimes do alpha and beta testing. So alpha testing is basically when your application is released to production to users who are internal. So alpha testing is usually done by internal employees of organizations, by friends and family of employees of organization, and a lot of internal users. So we as a team build an application, QA it, it looks good. Now, instead of actually just releasing it to everybody in the world, we release it to internal employees of the company. Let's say we have a large company. We release it to, for example, finance, whatever, marketing, anybody who wants to use our app. And now our employees who are not our QA engineers or who are not even in development at all, they have access to this app and they can actually play with this and do some testing. So this is alpha testing. Then let's say we are more sure that, okay, it actually looks good. Our employees don't have a lot of issues with this. Let's extend it and let's release to beta. So beta is when we release to the limited number of end users to obtain feedback on the product quality. So let's say we have some sort of list of our users who were using our product for a while, our old product, and they all are committed users. We can send them out invites and say like, hey, would you like to be beta tester? And if this person would like to be beta tester, they can actually like join the pool, get the application, and test it. Those are external users. They are not our employees. They do not work for our companies. They are not friends of employees and things like this. But those are public users. who access our application through either some sort of a link we provide or download it somehow through email that we send out. So there are actually quite a lot of jobs that you can find for beta testing. And if you're curious what it is, you can just look it up. They sometimes pay hourly. It's very popular for games. So if you're a gamer, usually games do a lot of beta testing. So before every major version, they would have like a beta version of the game, and people can actually go play this game, use these features that are not available to anybody else. And the only important detail here is that these users will need to provide the feedback about the product quality back to the company. So because here we have quite a huge audience, we can still use this feedback and significantly improve our application just by verifying that things are fine. At this stage, we have a lot of users with different devices, with different versions of operation system, different behaviors. So this is like the very last stage that companies can do before like fully releasing it. Again, if you work for a software application, for a software company and test an application, you won't necessarily be part of this, or you won't necessarily even see this, because not every company does it, like alpha and beta testing. Actually, here's a typo, alpha. Not every company uses this strategy. It's usually applied for very big, major products or for the new features. So that's when we do it. But again, alpha and beta testing are types of acceptance testing, very high level. Okay, the next thing I want to clarify here is E2E, or end-to-end testing. Is basically a technique when we follow the whole flow of the application from the very start to the end, and we verifying that our whole application behaves as expected. So some product managers actually call it full user journey. So if you hear something like, have you ever done full user journey, or have you ever tested user journey? Don't be afraid, this is what they mean. This is very simple actually. So basically what they do here is, let's say you're testing, for example, a DoorDash. So end-to-end testing of a DoorDash would be to create an account, sign in into that account, order some food, verify food has delivered, and provide feedback about it, and then probably sign out. Right? So the full user journey from the very beginning, from the moment of registration till the final moment of actually finishing using the product. So it basically tries to verify that the whole system works fine, the data gets moved properly from one component to another component, and the whole system works well as a whole piece. So this is E2E, or end-to-end testing. Okay, we're close. So the next thing I wanted to mention is regression, smoke, and sanity testing. You're gonna hear those words a lot. They're probably the ones that people use the most, especially when working with when working in QA and when doing manual regressions. Like manual regressions, that's pretty much most common word in the industry. So what are those? Smoke testing is the kind of testing that we do after we got a software build, and we want to make sure that certain critical pieces of the application are working good. So what we're trying to do here is basically, let's say we have a new build let's use DoorDash, for example. We got a new build. So the smoke test would be to make sure that we can log in, make sure that we can register, make sure that we can purchase some food, for example, make sure that we can log out, and let's say make sure we can make a payment, right? So really very, very large pieces of the functionality just to make sure that the whole application kind of still works, like it's not totally broken. So this is smoke. Usually very small set of test cases, can be 5, can be 10, usually no more than like 15. Depends on the size of your application, but still pretty small. So we do it usually right away after we got a software build. So just to make sure that we can actually continue working with this build and that it is testable. Another thing that is pretty similar to smoke is sanity testing. So the only difference is that sanity testing is usually performed when we have a software build, we receive a new build that actually got changes in the code. In this case, we also quickly verify major test cases, but we also try to make them around the functionality that has been changed. Also very quick, we got a new build, we quickly verify that users can still log in, register, make payments, but we also check that new functionality is there and it's kind of possible to work with this. Sanity testing. The biggest piece over here is regression testing. We perform regression testing in order to make sure that recent code changes or fixes, whatever they did, that it did not break existing functionality or existing feature. So we got a new build and we go test this build and we verify that everything that used to work before is actually still working as expected. There are no side effects on the existing functionality, right? So this is the regression. We want to verify that the whole thing is still working after some changes has been made to the actual application. Okay, before I move on, let me quickly look at your questions because I think I got a couple. Somebody asks me, end-to-end testing for the mobile application, will it start from installation and finish with uninstallation or still with sign in and sign out? So when we talk about end-to-end, it's more of a full user journey. So in this case, you can say that you will start from installation, register, do whatever is required, sign in, sign out. Uninstall would be good to add here. So I'd say for mobile, you can say it this way. But also, like if you just start with signing in and signing out, it's also considered an end-to-end testing because it's also a user journey. So both of your cases are actually end-to-end that you're mentioning here. Installation to uninstallation would be better for sure. Okay, and somebody else is asking me, so smoke testing is similar to end-to-end testing. Well, not really. Smoke testing is aimed to make sure that the major functionality works. So you can do some things like you can go ahead, quickly check registration, works. You can go ahead, quickly check payment, works. You can then go quickly check sign in, works. So when we do smoke testing, we execute a few small test cases. When we do end-to-end testing, we basically execute one giant, huge test case that contains of like 30, 40 steps. And when we have smoke tests, we usually have a short test case of like 5 steps each. So that's the difference. Okay. And the last slide in this classification is there are things like performance, stress, and load testing. So you will probably never do them, like really never. But I included them so you actually know what they are, and these words sound familiar and they ring a bell in case somebody's asking you, have you ever done this or something like this. We do performance testing in order to verify how our application is working under certain conditions. So, for example, we have our application, and we can open the page. So one of the performance testing types would be actually to check how quickly this page is loading. If you are a fan of Google DevTools, you can use them for performance testing of web. It's actually right here. So it's usually made by developers or by more of like technical QA engineers, not necessarily by manual QA engineers. And they usually use certain tools for this. Like Google Chrome is so awesome that it has one for us, but still you'll probably never have to do it. But this is kind of feedback that we get when we do performance testing. So we can say, okay, this is how long the page was loading. This is how long the JavaScript took. This is how long the rendering of the page took, and so on and so on and so on. So for people who are performance engineers, these numbers and things actually mean something. For me, not so really. I can probably just read this top charts and kind of understand things. But this is it. This is on the very big level. So how good our application is actually performing. Load testing is when we take our application and try to simulate the load of actual users. So let's say we know that we have 1,000 users who can be logged in simultaneously and do some things. So we create a test case that simulates 1,000 of users who are using our application at the same time. So the same amount of users that we usually have in our system, like around 1,000. And we check how our application behaves. Does it start working slower? Is it still okay? Is there any issues with data or things like this? Like if you take a website and really try to put let's say 10,000 people on it working simultaneously, you probably will notice that pages start loading way slower. And this happens because if we go back to our backend, front-end thing, on the backend, there is a server that handles everything. So now you have the server under this extreme load of people. And it tries to handle all the responses from all these people. So it is hard. Which puts us to the next one, stress testing. Stress testing is exactly what I just described. It's when we increase our load, increase the amount of users we try to simulate to the point where we try to break the application. So if our application usually has 1,000 users, the load test would be to like, okay, let's make 1,000 simultaneous users and verify that application is fine. Cool. Stress test will be something like, okay, let's do 1,100 users. Let's do 2,000. Let's do 10,000. Let's see when our application will significantly start failing for us. So we do stress testing intentionally to verify that basically how our application potentially can behave in case of a very, very heavy weight. Okay, cool. So again, this kind of things you will probably never do, but I hope that for you, in case you're asked Like, have you ever done this, or do you know what it is? On a very big level, at least you have some idea. When you're going through interview, when you're talking to people, and when you are working as a manual QA engineer, again, the main terminology, the main things you'll see and you'll hear will be black box, gray box, white box testing. You will hear something like functional, non-functional testing. You will hear positive, negative boundary testing. I do recommend you to actually spend some time with these definitions at least, because these are pretty common questions during interview, like what is a positive testing? What is a negative testing? Give me an example of boundary testing, right? So it should come up. You will very likely be working, doing, and seeing these three types as well. So smoke, sanity, and regression testing. So you should have a very clear definition and understanding what they are. So you can just use these slides to prepare, and I hope it was clear. Okay, let's move on. Let me quickly check on the questions if you had any, and we'll move to our next topic, which is huge. Okay, yeah, somebody sends me a very good example of load testing and stress testing. Cool. All right, very cool. So let's continue. Our next topic and our next thing that we're going to be talking about, in fact, let me actually share it with you. So you have it. I'll make sure it's actually visible. Can you copy? Okay, 1 second. We will share this in the materials as well, but just in case some people sometimes curious and they just open to follow me. Let me make it actually bigger on the screen in case somebody's on mobile. Okay, so the next topic is something that I actually called the process. It is basically a description of software development lifecycle. So we're gonna go through the whole process of developing a feature. So how these things are actually happening from the very beginning, how they come up, how they appear, up to the very end, like what actually happens after we release, and who's responsible for what. So here are a lot of actually abbreviations and maybe some words that will be not clear. If something is not clear, just you can just send me a question into the chat, so I'll clarify things. But I'll try to make it as clear as possible. There are a lot of parties to participate usually in the software development. So the whole process is pretty big. I highlighted the stages here. Everything that is selected in this green is when we QA engineers have to participate or need to participate. Not always, but sometimes. Another thing, some of the stages are not always happening, and I mark them with square braces. So if you see something with square braces, it means that sometimes it happens, sometimes it doesn't happen. It depends on the company, feature, team, and processes of the company, and many, many, many things. All right. So software development lifecycle, or how to develop and release a new feature. Okay, so where everything starts? Everything starts with the product team, actually. So the very first thing that you should probably know is there are a product team in the company, and we usually work with them pretty often, and we communicate with them pretty often. So product team is responsible for coming up with ideas, generating product ideas for a certain feature or for a certain product. Doesn't really matter. So they operate within in this world of what they call hypotheses. So hypotheses are their land. So how it actually happens? Product team members analyze the product. They also look at the products of our competitors, similar products, and so on and so on and so on. And they try to come up with some sort of idea or hypothesis in this case on how to either improve something in current product or on how to build something and add some sort of a new feature into this product. So let's say we have a product and our product has, here's an example for you, 1 second. And our product has 3 screens, 3 onboarding screens. So it has screen 1, screen 2, and screen 3. So a product manager says, hey, you know, actually on this screen 2, we only show people some sort of preview of our paid feature. And it's actually extra screen that users need to click on. Maybe we should remove it from the product in order to make sure that actually more users are using this product. So this is going to be like a hypothesis. So product person says like, okay, we currently have the product with 3 screens. In order to get into the app, user has to open 1 screen, tap continue. User is landed on the 2nd screen, tap continue, and then finally user is inside the app. And they as a product manager can think something like, okay, so why do we have to make user click twice here? Why not just remove 1 screen? And ideally, we will get more users actually inside the app. What if users actually read things in here and they don't like it and they just don't go here and just delete the app? So this is example of hypothesis. Hypotheses can be different. They can be whole new features. So for example, how about we implement the feature of notifications and things like this. So usually there are quite a few hypotheses. There are a long list of hypotheses that different product managers come up with. And then they basically store these ideas and they analyze them. And then they prioritize one of them or a few of them for implementation. So they have this list with the hypothesis that they think will potentially improve our product. And now they have a meeting, they decide, okay, which ones are we gonna try to build next? They pick 1 or 2 and prioritize it for implementation. So basically this is either the next ticket or the next feature or the next update of our application that we're going to be eventually working on and that we're going to be eventually testing. So they pick 1 or a couple. After this, they understand that like, hey, okay, so I have this idea in mind. For example, let's add notifications. Sounds fun, sounds good. But developers have to build these notifications and developers have no idea how it's supposed to actually look. So in order to actually add this visibility, product team goes and work with our designers. And then they come up with something which is called mock file. It's basically a giant file that literally includes the screens of our application, 1 by 1, and on the screens they will see basically the flow, right? So like similarly to here, but like way more screens. And if they want to implement something new, let's say they want like another button on the screen, it's going to be somewhere on the screen. So then developers, when they will have to work and they have to build it, they have this visual image on how it's supposed to be looking. So product people go and they work with designers to come up with this design, how the feature should look like, what color of the buttons there should be, what kind of font, what kind of text, what kind of animation, and things like this. So that's the third stage. After they talked to designers and designers made the design, at this point, basically product team is ready to start implementing this. So they usually organize a meeting with front-end engineers, back-end engineers, and sometimes QAs. Usually they forget QAs, but technically it should be also QAs. And they talk about this particular feature. So they say, for example, okay, we want to add notifications. Notifications will pop up on users' phones. This is the design. This is how your notifications will look like. So we want to store information on our backend if user has clicked on notification and if user opened the notification. And we want to visually show these notifications on user interface. So this is a part of front-end team. And obviously we as QAs will be eventually testing that functionality. So during this meeting, we basically provide feedback to our product team about this feature and about the flows that they implemented. So let's say they say that like, okay, we want to implement notifications. This is what it's going to be doing. Backend team will say, okay, so we probably need some sort of an API to send the information from user interface to our servers. Front-end team will be like, okay, so this is a notification. You want it to pop up. This is how it's supposed to be looking. You want this animation. This animation is hard to implement. It's easy to implement. And they basically provide the feedback. Sometimes the feedback can be like, Android engineers can say something like, well, I like your design, but this is not how notifications on Android should actually work. So things like this. Or sometimes the feedback can be like, backend teams can say, hey, we actually don't have any capability to store the information. We can't store this information on the backend. You guys figure it out. So things like this. It usually gets a little bit weird at first and then complicated, but that's basically when all the teams can review this and they start providing the feedback. So QA roles in here is relatively small. Just sit, listen, and try to understand what they're building. And always think, if you're part of this meeting, always think on how you would test it. So one of my first questions would be like, okay, are we implementing notifications on Android? Or on Android and iOS, how the application should behave. Let's say if user has the notifications turned off, and let's say we want to point user to turn the notification back on in the app, and how we do it. So many weird questions. Also, valid questions usually are about the compatibility, like, okay, are our notifications on Android 9 should work the same way as our notifications on Android, let's say 4, and do we even support this feature for 4? So things like this. So you want to have a clear understanding of all these things and what you'll need to test at some point. So yeah, that. After this meeting, we usually provide some feedback, and this meeting, in fact, happens 2, 3, 4 times. So after we provide the feedback, product team updates the document, They go back to their designers. Design also gets updated if needed. Very often they forget about flows. They simply can say something like, okay, we want, for example, we want this notification, and they can have a design flow on how user can turn notification on, but there is going to be like no design on how user can turn notifications off. And I'd be like, okay, so how do we turn it off? So things like this actually happen all the time. Basically they go through these iterations with us and try to make sure that the documentation is fully ready for us to actually start building things. So after a few iterations, designs gets updated if needed, and everybody usually agrees on the feature that they're implementing and how they're going to be implementing it. So at this point, product team creates what is called user stories and puts them into the backlog. So user stories is basically tickets, and they describe a software feature from the perspective of a user. So how a user would work with this feature, and it basically describes what kind of user is using the feature and what a user is trying to achieve, like what this user wants by using this feature. So it's like a simplified requirement. So as a user, I would like to see a notification for, I don't know, submitting a payment. As a user, I would like to be able to turn off my notification for submitting a payment. So those are just examples of user stories, just off the top of my head. Very simplified requirement from the point of view of the end user. So basically this whole giant document or design document, that PRG document too, that gets created at this stage, is basically gets broken into small pieces. And those small pieces are usually user stories. And then product team puts them into backlog. Backlog is basically a list of all the tickets that are ready for implementation, but that we are not working on them yet. So let's say we want to implement this bug fix, this feature, this user story, but it's not prioritized. We will do it sometime eventually in the future, but not now. So all those things, they are stored in the backlog. Backlog is basically the list of items that will eventually be implemented at some point, not yet prioritized. So they create user stories and they put them into the backlog. Then we have the sprint planning meeting. So sprint is basically a cycle of development, like a cycle of iteration of development, and it's usually short. It's around 2-3 weeks, depending on the company and the processes. And sprint is basically this period when we working on certain tickets and certain items. So when we have sprint planning meeting, we basically plan our work for the next, let's say, 2 weeks, for example. So in this case, during the meeting, we actually take these tickets, these user stories from the backlog, and we pull them into the sprint. So we're basically committing, we're saying like, okay, the next 2 weeks, I'm gonna work on these user stories. But like I mean developer. Developer is gonna work on these user stories. So engineering pulls stories, bugs, enhancements, tasks, whatever, into the sprint. And what's also important, they try to make estimations as good as they can. So let's say in order to implement notifications on the front end, it's going to take me, I don't know, 5 days. So they're going to have a user story where a user can enable a notification, and they're going to estimate it to 5 days. In order to send information to the backend, backend will need, I don't know, 6 days. So all this information, and they work in parallel. So all this stuff gets estimated and put into sprint. Then sprint begins, and when sprint begins, developers start working on these tickets that they see inside the sprint. And usually within first 2-4 days, we usually don't get anything from the developers. Developers are simply working on these items and these stories, bug fixes, whatever they have in their sprint. It can take longer. Like if the feature is huge, it can take a week or even 2 weeks. But usually we try to do like small features, small increments. So usually the first 2 to 4 days, we don't get anything from developers. And after that, they actually start making the first builds. While we are waiting, at this point, we should have the finalized document with user flows and with the requirements. And while developers are working on actually building feature, at this time, we can work on the test cases. So this is the time when we can start creating our test cases for this future feature. So we will be like, okay, so let's create a test case that verifies that user can turn notification on, that user can, second test case that user can update notification, third test case that user can delete notification, things like this. So at this point, we start working on documentation and particularly test cases. So after a few days into sprint, we usually get the very first build from our developers. And when we get the very first build, the first thing we do, smoke testing and some exploratory testing. So we want to make sure that it still works, like the major functionality is okay. Users can log in, create accounts, log out, make payments and things like this. And we can start quickly looking at this new feature. So we can at least check like, hey, is this feature actually working? Is this accessible? Like, do I even get at least one notification? So things like this. And developers start slowly moving the tickets for testing towards us. So they like reassign their tickets from in progress, like from development category into QA category. So we start getting these tickets. Then we usually have a few iterations. So we will be reporting bugs. We will start doing some testing. Developers will be fixing these bugs, sending us the new builds. We will be breaking them again, reporting the new bugs, and things like this. So that will happen for a few iterations. Usually at least 3-4 times, depending on the feature and how hard the feature is. So you'll be just sending builds back and forward. And you'll be just getting new builds with fixes to verify that things are fixed. So at some point, they're gonna do the code freeze. So when they realize that, okay, major functionality of feature is good, it is working, it's time to say, hey, we're gonna have a code freeze. Code freeze is this moment of time where they start implementing this additional rules of actually committing the code and making changes. So let's say they can say something like, hey, so there are going to be no more major changes, only bug fixes will go to the current build. Like no more functionality changing, we're not updating anything. All we can do is bug fixes. So they say it's a code freeze. And after the code freeze, all they do are bug fixes, and that's it. Not every company has code freeze, but if your company has, this is what they do, basically. Like at this point, they have additional restrictions to committing and doing more changes for the product, for the build. And they create RC. So RC is release candidate. Um, Release candidate is basically the build that can potentially go to production. It's a candidate for our release. So RC not always is the most perfect build. Sometimes there can be a few of them, but basically it's like one of the final attempts. Basically, it's like, okay, so we are at this stage where the feature is mostly working. There are not that many bugs. Let's do the release candidate at this point. So this is going to be the major build that you will have to retest eventually. So when you have RC release candidates, that's your time for starting regression testing and for finishing up your tests of this new feature. So by the time you had RC, you usually had a few iterations on this new feature with your developers. So your new feature by this time is usually very, very well polished. So at this point, you start doing regression testing, the one we just described, and you try to verify that the rest of the functionality of your application, that it simply didn't break, it still works as expected, and you also wrapping up your tests for the new feature right here. So if everything goes well, you do the very last final round, which is called the release acceptance testing. Again, this and this are very similar, so not every company does a specific round of release acceptance testing. So sometimes company like do the final testing of the build, but majority of company, if everything went well during the final regression and final test of the new feature on RC candidate, they kind of treat it as release acceptance testing. And at this point, we basically say, okay, the build is good to go. If you have test automation or work with test automation engineers, they're gonna have their suite of regression, and when they have RC, they're gonna run the release acceptance tests, or they're gonna run regression tests against the latest candidate, if those people are there. So this is where they also help. So product team at this time understands that, hey, release is close. Let's prepare the release notes. So they preparing this release notes about the product. So if you see like inside app stores, sometimes they like roll out the new version of the build and they say like, we fixed the bugs, we added this new feature and this new feature, and our app became better. So those are release notes. Basically, this publicly available information about what we have changed in our software, in our application with the latest update. Okay, then the favorite, release to production. So all this testing from before is usually made in a certain test environment or QA environment. And after everybody signed out, like QA signed off. QA signed off the build and said that, like, okay, the build is good to go. Product signed off, said like, okay, looks like this build is good to go. After this, we make the release to production. And after that, we do production testing. So here, it really depends on the product. Usually companies do production testing after the feature has been released. So they actually go to production accounts. We verify that things are working properly in real environments, that users are still using the system, but there are exceptions. Some companies cannot do production testing, for example, finance companies. For like, I'm working for a financial company, and it's extremely hard to do production testing because Let's say every time I need to create a new production user, it's basically the same as creating a new absolutely real banking account. So it goes through a lot of operations around FinOps and things like this, and it's very, very hard. So we don't really do a lot of prod testing. What we do is like we sign in into our production account, verify we can sign in and see things. But majority of companies are not like that, and they will actually go to their production and test things pretty carefully. Sprint ends. If there are any issues, we do hot fixes. And after the release, we still do constant monitoring of our production. And our best friends here are our product managers, marketing, CS, which stands for customer support or customer success. This is basically what they do. When they release to production, users get the new version of the application. And if users have any issues, they're going to complain to customer success, like, I cannot log in, I cannot make a payment, I cannot make a purchase. Help me, what do I do? I'm stuck on this page. So users contact our customer support or customer success, how people call it these days, and complain. And those are our best friends. When something like this happens, customer success teams usually contact engineering and product and say, hey, like I have this user who says he can no longer log in and his account looks fine. Like, what guys did you do? And sends us some information. Or he can say something like, hey, I have this user who's stuck on this screen and cannot navigate away from the screen. What do I do? And if we have like a few tickets like this, it really means that we missed a bug. So we go back and we do hot fixes. Marketing people actually usually have tunnels and marketing funnels. Funnels. So when user goes through one screen to another, let's say here, user journey. So user goes to one screen, second screen, and third screen. Usually marketing people have some sort of system that is tracking user activity. So every time you clicked on this user, the information went to marketing, okay, users on this screen. Then you clicked on this user, information went to marketing that, hey, user is on this screen. Every time you clicked on this one, hey, user is now on the third screen. So imagine they have these funnels and they have approximately the same amount of users. It usually goes like from top a little down, like less and less people make it to the end. But imagine at some point it breaks. So it used to be like this, and now it's like these two screens, and like nobody can actually access the third screen. There is marketing data that basically says that users can still navigate among these two, but they cannot do the third one. So in this case, marketing is gonna probably alarm and say like, hey guys, can you actually go and check the application? Can actually users access the screen? Something is not working. Or maybe we broke marketing, which is also possible. Okay, and another thing is product. Product monitors users' reviews. So if user is submitting a terrible or not great review about your application into your app store, or just tweets about it, and actually there are a lot of tweets about things not working. If you work for a large company, you'll get them regularly. So product team monitors all this activity, and if they see something weird, they will also like get back to us and say like, okay, we think there is a problem. Can somebody look into this? So this is the prod monitoring that happens after. At the very end, we usually have a sprint retrospective meeting. And sprint retrospective meeting is a meeting among our engineers, QA, product, where we all sit together and discuss two questions. What went well during this process, during this sprint? And what didn't went good, and what basically is the area of improvement. So what went well, and what are the areas of improvements? So basically, what didn't go good. So we usually try to like name some things that we liked and name some things that we didn't like. Let's say we were supposed to deliver something within 2 weeks, but it actually took us 5. Sprint retrospective meeting is going to be the meeting where we all going to be discussing why exactly it took us 5 weeks instead of 2, and what can we do better the next time in order to avoid this kind of cases. Trust me, they happen all the time. So things like this, and vice versa. If we have delivered everything on time and the quality eventually is good and looks like everything is working, cool. What did we implement? What did we make during this last sprint that it actually worked so good? Maybe there are some sort of practices that we had, and let's try follow them in the future. So this is the process overall. I hope it makes sense. And in case somebody asks you, like, from about your previous experience, or for example, when do you think QA should be involved in the process? How much QA should be involved in the process? Which stages of software development QA is involved into? You can basically follow this document. So technically, ideally, QA should be involved as early as possible. On the very first stage of like initial documentation review and creation, QA should be involved, and we should be reviewing the first product documents and providing the feedback. Trust me, there are a lot of holes. Like, product constantly forgets about pieces of the flows, and then you find things like, okay, you can log in, but you cannot log out because nobody added log out button in the product document. So things like this happen all the time. So that's why QA should be involved as quickly as possible in the beginning, during documentation. Then we obviously participate in the planning, we do the testing, and we test in stage and then in production. So if somebody's asking you, okay, what is the last activity during sprint? So let's say you signed off the build is good to go. What do you do next? Like, you tested in staging, or you tested in QA environment and everything is good. You tested your release candidate and everything is good. Do you do anything else? Are you done? Yes, you do production testing, right? So don't forget about production testing. And if somebody is asking you, let's say, what are the stages? What things you do during the testing? You can definitely talk about, okay, I test in QA environment. When we get the first build, I do smoke testing, some exploratory at the very beginning. I then do regression, there it is, release acceptance sometimes, right? So things like this, those are your testing types, and this is basically when you see them in the process. Okay, one quick comment about here, and I'll go to the next thing. So this is the flow of Calm application, and those are 3 screens that users see when they are actually are registering. Onboarding. So they just downloaded the app, and this is what they see: this screen, then this screen, then this screen. So let's say your user story, your goal, your feature, or your task is to remove onboarding screen 2. Like, your product manager says, hey, I want to get rid of this screen because I think that we have a lot of users here, we have less users here, and we have not so many users here. Probably people don't like something on the second screen. Let's get rid of it. So in this case, the requirements will be to remove the screen too. And the second requirement would be when user is on this screen and clicks continue, the button should take user here, right? So at first we get rid of the screen, but we also have to link this button to now take to the new screen. So the user stories in this case will look something like this. As a user, I do not want to see onboarding screen 2. And the second story will be, as a user, I want to be taken from onboarding screen 1 to welcome screen. So those are just the common format for user stories. So when you see something like this, don't be surprised. That's basically how it usually looks in real life. So sometimes, majority of our time, our product lives in the world of hypotheses. So our product manager, he or she, they like, okay, so I think if we get rid of this screen, it'll be better. We'll have more users in the system, but we are not sure. We don't know for sure. Is this going to happen, or is this just in our heads? Maybe nothing will change. Or maybe we'll actually make worse. Maybe we'll have them less users. Who knows? So very often they don't know if the flow that they build or if the feature they build is good or not good. And are users going to like it, or are users not going to like it? So this is the case when they implement something that is called A/B testing. Let's go here, and I hope it'll make some sense. So A/B testing is basically when, first of all, it's not the testing that QA do at all. It's just called testing because people are testing how our users interact with the system. So we have our users, 100% of our site visitors, for example. We show some of them one version of the site. So for example, green button. We show another group of users, blue button, for example, and a little bit of different version of the website. So we split our users into 2 categories. One sees one experience, another group sees a different experience. And then we measure, like how many people here clicked on this button versus how many people here clicked on this button. So if more people clicking on the blue button, then people obviously like the blue button more. It works better. In this case, we get rid of this, and the 100% of users, 100% of our site visitors, for example, start seeing this flow. So this is A/B testing. It's done through certain applications that can actually control this kind of things, and it can be implemented to mobile apps too. In fact, majority of applications you work with every day have hundreds of A/B tests and constantly testing users and constantly trying to figure out how to make users do things they want, like buy, click on ads, and do whatever. And A/B testing is a huge help in here. So very often when we implement the feature, product, because originally it is a hypothesis, have no idea if the feature is going to work or not. So a common practice is actually to build this feature, like let's say we are updating it. And now we have 2 screens, but we will then release and we will show these 2 screens at first to only 10% of the users. Remaining 90% of the users will still see this old flow. So we then will look at this 10%, not we, like product people, we'll look at this 10% and they're like, okay, so this 10% seem to be happy. They seem to click on this, land on this screen. So how about we increase it? So then they bump their A/B test to a classic 50-50 split. And now we have 50% of users seeing this flow and another 50% of users seeing this flow. So then they measure. They run this experiment for, let's say, a month or maybe 2 months. And at the end, they will measure that, like, okay, so after 2 months, we had, I don't know, 500 users started here. with this flow, and 200 ended up being in the app. And we also had 500 users started here, but here only 100 users ended up being in the app. So in this case, it's obvious that this flow is better. We have more users at the very end, better retention. So they will likely get rid of the old flow, like simply turn it off and just keep this 2 screens. So nobody will see this 3 screens anymore. And vice versa. If, let's say, it didn't work, so users who see 2 screens are actually like less happy than users who see 3 screens, then we're gonna keep our 3 screens, and we're gonna get rid of the feature. So why I'm talking about it is because it adds, as you may guess, additional complexity to us. So now, instead of testing one flow, we have to test 2. In fact, we have to verify that both of these flows are there and that the both are working. The old flow is still there and then the new flow is still there. We usually do it using some sort of management tool that will allow, like, let's say you register the user and you can force this user to see this flow or the second flow. But let's say you have 3 or 4 features that are under A/B test and you are doing regression testing. So when you do regression testing, your old features, they have these 2 flows. Sometimes they can have 3 flows. So the complexity of testing really increases with the A/B testing. And this is something for you guys to remember, that sometimes if you have A/B split, you need to test both versions and verify that they're still working. What's interesting about modern development, you can spend, like from my personal experience, we've spent 4 months building a feature. And after we A/B tested it first, it wasn't really good. So we increased the split to 70-30. So like 30% of users got new features and 70% were still using old application. And it was terrible. So we spent 4 months of development and then we threw that feature away. So this can also happen. Don't be surprised. That's okay. That's that's provides us data about our user behavior. So this is A/B testing, again, this is not a type of QA testing at all. This is a way for product managers to split the flows and actually test the flows and verify that and check which flow is better, this one or this one. Okay, what else here? So another thing that I want to mention here is this stage, and it's called the hot fixes. And let's quickly talk about hot fixes and what they are and when they are needed. So hot fixes, as you may guess, are bug fixes that are extremely crazy important. And they usually happen after the production release. So we released something, and then let's say our users start contacting our customer success or providing bad reviews, or something dropped in marketing funnel, and we realize that there is a bug. So we go to our application, we open it, and we go follow this flow or follow the steps that user told us to follow, and we find a bug. And the bug is pretty critical. So for example, user stuck on the screen and user cannot move away from the screen. So if this happens, in this case, basically, we need to implement the fix, and we need to do it right away, as soon as we can, because we know that many other users will probably stuck there. Or let's say users cannot register anymore. So something crazy like this. So in this case, we can try to implement a hotfix. So developer, one of the developer really only works on one bug fix for this particular issue. After he or she fixes the bug, they send the new build to us with this particular bug fix. critical one. We quickly retest everything and then we push this build to production. So developers are usually very careful, and we are very careful basically to say do not touch anything else. It's really just this. So we really try to fix only one little thing that is a blocker for our users, and it's a very important bug. And then we basically make a whole new build and we release again a whole new build to production. But that new build literally made of just one bug fix. So when something like this happens, you then release, you go to production, and you also need to verify that the bug is fixed. So that is a hot fix, and it's very unfortunate if they happen, but sometimes they do. Okay, let me quickly look through this and make sure I did not forget something. And I have a remaining list of questions. By the way, if you have any questions, let me know while I'm looking at the rest of the questions for today. So I make sure to cover those. Okay. All right. One question. How long does the code freeze take? Which is a good question. So the code freeze, as I mentioned, is basically when we add additional restrictions. We like say, okay, so this build is about to be done. There are no major changes that we will be adding to this particular build. And only bug fixes. For example, only bug fixes will go to this build. And it usually happens after the build is relatively stable. So then we basically call this day code freeze, and it lasts until we basically release, right? So it depends how long it will take us to retest RC and how many RCs we get at the end. It usually lasts about around 4 days, but it really depends. It can be 2 days if we release quickly. It can be a week if all of a sudden we found some issues on RC and we now have to fix a lot of bugs. But usually I would say it takes around 4 days. Okay, cool. What else? Let me check. So duration of sprint, 2 to 3 weeks, as I mentioned. Sprint, like it really, the company, they try to establish their own processes and their own like development practices. So usually when companies trying to push for like small changes, and this is a startup or a smaller company, they try to make a very short, small iterations. So they would probably go with 2-week model and say like, okay, about 2 weeks, we deliver one short feature, one small feature, we'll push it and we'll test it, A/B test it, make sure feature our user likes our users like our feature, and we're good to go. At the same time, something bigger that can take 3 weeks. If feature is huge, like really major, and requires, for example, a month or 2 months, it actually makes sense to break it into a few sprints. So don't think that one feature should be done per sprint. If feature is huge, sometimes it can take 2 or even 3 sprints to actually complete a certain feature. 3 weeks are usually for development teams that are a little slower or have more people, like bigger companies can go with 3 weeks model, but it really depends on the product and the processes of the company. If you get this question, like describe me the sprint or the sprint process, you can basically answer this question by saying like, okay, our sprint was around 2 weeks, and it would start with like before sprint, we would have sprint planning. Then we would start, developers would start working on things like on features, on bug fixes, while we were working on QA test cases and documentations. Then we would do a round of testing, smoke testing first, and so on and so on. Then we would have some sort of code phrase at the end, during which we would complete our testing of our RC candidate, release candidate, and then we would release and verify that things are done in production. Actually, another good question. So usually sprints start in the in the middle of the week. So usually they start on Tuesdays or Wednesdays. Here is the thing: we try to never release on Fridays. So if your sprint ends on Friday and you're trying to release, it means that you have to release on Friday. And this is a very, very bad practice. So if somebody asks you, when do you guys release? A better answer is to say weekdays. So anything Monday to Thursday works. A general rule about it is that we do never release on Fridays, and we try to never release after 2 p.m. or 3 p.m., usually after 2 p.m. Why? Because let's say you released a new feature on Friday, you tested it in production, looks fine, and then on Saturday or even on Friday night, your users start complaining, or your product starts getting negative feedback about your application. And in this case, you really need a hotfix, or you really need to do a rollback of your application. But it was Friday and your developers are simply not there, so it's weekend. First of all, you're not guaranteed to find your developers on the weekend who could actually do this. And also, even if they will agree to go ahead and help you out, you will also need to find QA engineers who would agree to test things on weekend, product people who would agree to verify and work with all of this group on weekend. And nobody really wants to work on the weekends. So better just be safe and release during weekdays. Even if it's Thursday and you have some issues discovered during Thursday night or Friday morning, you can still fix things on Friday, or you can still revert. So that is a common practice. And similarly with releasing after 2 or 3 p.m., if you release, it's going to take some time before you start getting some negative feedback from your users or from other from whoever's using your app about bugs or about maybe not nice of experience. And you'll probably get this feedback during night, and you will only discover it in the next morning. So you basically at risk of leaving your users with a broken application for a whole night, and next morning before you actually started to fix things. So that's why releases usually are done in the beginning of the day, preferably, and during the weekdays, except for Fridays. The only exception here can be done for hot fixes. Like if it's really bad and we really have to fix something, it's like drop everything, let's fix the situation. In this case, we can actually go ahead and do the hot fix. All right. So the very last thing from me over here is something I wanted to talk to you about, is the situations when we revert, when we try to basically re-release something and it's really bad, so we try to go back. I think I can stop sharing for now, and let me start the video. So cool. So reverting, and yes, you can actually write some questions because we have, I think, 15 minutes left. So I'll make sure to cover that. So if you are testing the application and your application is has been released, you think it is okay, but then all of a sudden you actually find some sort of a critical issue or issues, there are two ways to fix the problem. One way is actually to go ahead and do the hotfix. So let's say, okay, we know that users can sign in, they can register, but they are stuck on this screen and it's pretty terrible experience. Let's go ahead and fix it. So you report this issue, developer takes it, it fixes it, they fix it, and then you try to re-release. In this case, you will eventually release the fix for this and user will get a better version, but it's going to take a couple days, especially if you work with mobile applications. So in order to release a mobile application, you actually have to submit your build for approval to the App Store or to the Google Play, right? This is what our developers do. And Google and Apple have to review your build and say, okay, it's good to go for the users. So yes, basically then you wait for them to review it. For Apple, it usually takes about a day. For Google, it can be faster. And then you can release this build. So hotfix means there are going to be some time waiting. And after that, you will release your build to the users. So another thing that you can do, let's say you release something and it's so broken that it needs to be removed from production. And another thing that can happen is a revert. So reverting means that you are taking your current build and you're reverting back to the previous one. So you just released version 3 and now you're like, oh no, this is really bad. We want version 2 back. And you go and basically go back to the version 2. And now your users are still seeing version 2. So reverting back is not always possible, unfortunately. That's one of our safest options and the best ones. It's usually pretty easy to do for web, but it's almost impossible to do for mobile. For mobile, again, we still have to go through the app submission process. So if your developers are building an application and they're really not sure about the quality of the build, sometimes it's actually recommended to submit to the store 2 versions of the application, the current one again and the new one. So if the new one doesn't work, you can actually take the current one that has been approved and put it on top a little bit ahead. This is like go around of reverting things on mobile, but that's the difference, right? So hotfix is actually pushing a new build with a fix, and reverting is actually going to the previous version and totally getting rid of the whole new feature in order to save users because something bad has happened. Reverting, not always possible, unfortunately. Okay, let's see. Actually, yes, good question. I have, there are 2 more interview questions from yesterday. Let's actually go over them because we did not cover them. So let me quickly open my list. of questions, and let's see. This is not it. Okay, here we go. 1 second. Okay, so yesterday we looked through most of the interview questions, but we have two of the questions that we have not covered. We actually have a few more, but they will be covered tomorrow. But the ones that we did not cover yesterday, so there was one question: are you a team player or are you an individual contributor? So this question can be asked during interview, and it aims to find out your personality and what kind of team you would like to work with technically. So when answering this question, try to adjust for the environment where you are trying to work and where you try to actually apply for a job. So here is a trick. If you are at the interview and the company has a QA team and you obviously are going to be working with a QA team, I guess it's better to say that you enjoy working with a team and you are a team player. At the same time, if you are applying for a job and you're going to be the first QA engineer, I think it's also a good idea to say that you are a great individual contributor. Also, you do enjoy working with a team. You can always say that you like boss and you're good at boss, but I would try to stress the one that is more applicable for this particular job. Again, if you have some sort of preferences, like for me, really, I don't really have preferences. I've been the first QA in like 2 different companies, and it was interesting. And I've been working with teams in multiple companies too, and it was also cool. So I liked this way and the other way. But if you are only towards teams, probably you can stress it. But again, if you don't really care, try to think from the position of where you're going to be working with. Maybe they have a large team and they want somebody who would just simply match this team. So this is a good one. Okay, one more. And this question is a little bit similar. What do you like at your current role, or what do you enjoy at your current QA position? So basically here it's really up to you. Good answers would be similar, like, well, I enjoy working with a team. I enjoy being in IT industry and working in tech. I enjoy being in like challenging environment and working with application, trying to actually find bugs, and I enjoy that I actually can make a difference by finding these issues and potentially improving experience of millions of people, whoever is using your app. Millions probably too much, but thousands of people, whoever is using your app, right? So things like this, you can definitely mention. Another thing is, again, if you want to target and tailor for a position a little bit here, you can also do this. So let's say you are applying for the company that is, for example, a large company, and they have like a lot of teams and very structured. If you have something at your current company, like let's say processes or whatever that you can mention, you can say that like, hey, I enjoy working with settled processes, because large companies definitely going to have settled processes. I enjoy the ability to grow the career path, right? When you join the big company, they usually have something that is called the career path, where they say, okay, so you are, let's say, QA level 1. This is what you need to do to be QA level 2, and this is what you need to do to be QA level 3, and you can actually grow by just achieving these skills. So things like this. Similar to this question is, why would you like to join our company? Usually the question that people really don't know what to answer. You can also tailor a little bit. So if you are applying to a large company, you can say something like, well, I enjoy working in an environment where everything is settled, there are processes around things. Things are well defined. There are certain procedures in place, defined career matrices and things like this, right? So that's why I would love to work for a larger company, and this is kind of experience that I'd like to gain. If you are joining a startup, or if you are interviewing for a startup position, what you can say here is something that like, well, I'd like to learn more. I'd like to like work and communicate with many different things. With many different teams. So when you are joining the startup, usually startup is messy a little bit at least, and they don't know the processes. The processes are to be defined. They just try to push and release, but at the same time, it's very challenging. This is the environment where you can learn a little bit of development, a little bit of automation, a little bit of, I don't know, finance, who knows. And you really get a lot of experience. So like through my career, I mostly worked for startups, and I learned a lot of things. It's just simply because sometimes there's like, okay, we need a Jira admin. Who wants to be a Jira admin? And nobody wants to be a Jira admin. Lana, how about you try? So things like this happen in startups. So you can basically say that you'd like to learn more. You like to communicate with many different teams. You like to have like a bigger overview of the whole product, because usually startup has some sort of a product, but it's not like they have one department that is working on this feature, second department that's working on this feature, and the third department that's working on this feature. It's usually like, all right, we all are QA engineers, we're QAing the whole product together. And if you have a large, big company, they're going to have this split, right? So if you're applying for a job in startup, you can also say that, like, I'd like to learn the whole perspective. I'd like to learn about the whole product. So that's just as an idea to use. Okay. Let's see. Do we have any more questions before I wrap it up? Okay, one good question. We quickly went over that yesterday, but I will answer yes. And let me quickly read your comments. Okay, cool. So one final question, and we'll call it done for today. Lana, can you give me an example of testing the elevator, doors, floors, buttons, and what else? So we quickly covered that one yesterday. There are a lot of options. I personally was asked a couple times about the Bay Bridge and about the chair. So in this case, your whole approach is actually to verify that you can, first of all, to ask if they have any requirements. So before you start explaining everything or anything, ask them, do you have any requirements? So they say, like, how would you test a toaster? Do you have any requirements? So usually they say they don't. If they say they don't, then in this case, we start from functional and positive tests, and then we slowly move on to the least important negative test cases. So no matter what you're answering about, first of all, ask about requirements. Always ask about requirements. Even if they ask you, how would you test a sign-in form? What are requirements? This is like the first thing. And then move on and actually come up with the test cases and say like, okay, so at first, the most functional things are this, like the door can be opened and closed. Let's verify this. It matches a certain shape. And things like this. And then at the very end, you verify things that are non-functional and less important. Things like color, things like stress testing, load testing. So those goes to the end. So this is a whole approach to this answer. I hope it makes sense. This is one of the worst questions in my opinion, but just try to be, try to follow in the pattern. Do you have the requirements? If you don't, functional, non-functional. If you do, against the requirements, again, functional, non-functional. So cool. This is it. Thank you guys. Thank you so much. It was nice seeing you. I did record everything, so we will share the recording. And I'll see you tomorrow again. Tomorrow, Max will be explaining you finalizing your LinkedIn. And we will talk a little bit about more interview questions and the job offers, negotiations, and terminology. So I hope that will be useful. Cool. Thanks, everyone. Thank you who made it. Bye-bye. Have a good night.